There are thousands of you, not in other universes, in this one. The you of one remembered summer afternoon, the you of 10 minutes ago. Each one felt completely present, completely whole, and an 80-year life holds about 2.5 billion seconds, every one of them, containing a person certain that their moment was the moment. Common sense says those selves are gone, and only the you of right now exists. But here is what nobody told you. Physics cannot find your right now. No experiment has ever located a universal present moment. The satellites over your head already correct for its absence. 38 millionths of a second, every single day. And an ordinary evening stroll is enough to shift what counts as now in a distant galaxy by 4 entire days. By the end of tonight, you will understand the single idea underneath all of this. The idea Einstein used to comfort a grieving family in the final weeks of his life. Before we begin, if slow questions about reality are how you like to fall asleep, a quick like or subscribe truly helps me keep making these. It costs you a moment, and it means the world to me. Now, let's begin. There is a question so simple that a child can ask it, and so hard that no physicist alive can answer it. The question is this: what is time? Not how do we measure it, not what do clocks do. What is it? The thing itself, the thing you are moving through right now, the thing that is carrying you from the beginning of this sentence to the end of it. Physics can predict the wobble of a pulsar 3,000 light-years away to the width of a hair. It can tell you what the universe was doing when it was a trillionth of a second old. And when you ask it what time actually is, it goes quiet. Richard Feynman, one of the great physicists of the 20th century, and a man who almost never met a question he wouldn't take a run at, gave what may be the most honest definition anyone has ever offered. Time, he said, is how long you have to wait. And you cannot really say much more than that, he suggested, without getting into trouble. Think about that for a moment. The man who helped build quantum electrodynamics, a theory tested to better than 1 part in a trillion, the most precisely confirmed theory in the history of science, looked at the most basic quantity in every equation he ever wrote, and defined it with a shrug. Time is how long you have to wait. Keep that sentence somewhere close tonight. By the end, it is going to mean something very different from what it means right now. Notice, too, what Feynman's definition quietly does. It defines time from the inside, from the standpoint of someone stuck in it. Waiting is not a concept from physics. There is no waiting operator in any equation, no unit of patience in any table of constants. Waiting is something only an experiencer can do. Every other fundamental quantity in physics can be defined from the outside, impersonally. Charge is what couples to the electromagnetic field. Mass is what resists acceleration. But when the most plain-spoken genius of 20th century physics reached for time, the only honest handle he could find was a feeling. That should strike you as odd. It gets odder the longer you look at it, and looking at it longer is precisely tonight's plan. Feynman was not the first to run into this wall. 16 centuries earlier, a scholar named Augustine sat down to write about time and produced a confession that philosophers still quote today because nobody has ever improved on it. What is time? He asked. If no one asks me, I know. If I try to explain it to someone who asks, I do not know. That is the strangest kind of knowledge there is. You have been inside time for every second of your existence. You navigate it flawlessly. You show up to appointments, you remember yesterday, you plan for tomorrow, you feel the afternoon slipping away. By every practical measure, you are an expert in time. And the moment someone asks you to say what it is, the expertise evaporates, and you are left pointing at a clock, which is a bit like answering the question, what is music, by pointing at a piano. Here is what makes this more than a philosopher's parlor game. Physics, the discipline that has answered so many unanswerable questions, that told us what the stars are made of and what matter is doing when nobody looks, has a genuine problem with time, and it is not a small one. and it is not at the edges. Most people assume the mysteries of physics live far away, inside black holes, or at the first instant of the universe, or down at scales 1,000,000,000 times smaller than an atom. This one does not. This one is here, in the room with you, woven through the most ordinary experience you have. The problem is not that time is complicated. The problem is that our best theory of it, a theory confirmed by every experiment ever thrown at it, a theory your phone quietly relies on every time it finds your position on a map, describes something that does not look like time at all. That theory contains an idea. One idea. It can be stated in a single sentence, and we will build up to that sentence slowly, piece by piece, over the next 2 hours, because if it is dropped on you all at once, it simply bounces off. It sounds like wordplay. It sounds like something a student says at 2 in the morning. But it is not wordplay. It is the sober, experimentally supported conclusion of the physics that runs your satellites and corrects your clocks, and it is arguably the single most consequential idea in the modern scientific picture of the world. Some of the people who understand it best have called it the deepest thing we know. And here is the strange part. It is barely advertised. You can go through years of schooling, watch 100 documentaries, and never once have someone sit you down and walk you through it from the beginning. Consider how deep the paradox of familiar ignorance runs. You use time in nearly every sentence you speak. The words before, after, soon, already, still, yet. Your language is soaked in time, the way a fish's gills are soaked in water. Your body runs dozens of clocks without consulting you. The roughly 24-hour rhythm that makes 3 in the morning feel like the bottom of the sea, the heart's steady second keeping, the split-second timing that lets you catch a falling glass before you know you have seen it fall. You are, by construction, a time-processing machine of astonishing sophistication. And none of that machinery, none of that fluency, brings you 1 inch closer to being able to say what the thing is. It is entirely possible, hold this thought gently, that the fluency is precisely the obstacle, that what we know so well from the inside, we may be structurally unable to see from the outside. Physics, as we are about to discover, ran into exactly that suspicion, and had the discipline to keep going anyway. So that is what tonight is, a slow walk, from the time you think you know to the time physics actually describes. Along the way we will meet a Swiss patent clerk who noticed something odd about trains and lightning, a mathematician who told a room full of scientists that space and time were about to fade away into shadows, a letter written by a dying man to comfort a grieving family, and a question asked by Stephen Hawking that physics has never managed to answer. We will also meet you, or rather, thousands of you, because one of the first things this idea does is quietly multiply you into a crowd. There is no rush. That is worth saying plainly, here at the start. Nothing in this story needs to be held onto with effort, and nothing later will punish you for drifting. The idea assembles itself slowly, the way a picture assembles in developing fluid, and if you fade before it is finished, it will simply be waiting for you, whole, the next time you come back. In a story about whether moments can ever really be lost, that is not a small comfort. It may even turn out to be the point. But before any of the physics, before the trains and the clocks and the shadows, we have to start with something much closer. We have to start with you, and with a simple bit of arithmetic about your own life that you have almost certainly never done. Because the question, what is time, sounds abstract until you notice what it does to the person asking it. Augustine knew time until he was asked. Feynman measured it without knowing what it was. You are living it right now without being able to say what it is. And it turns out that the moment you look closely at the you who is living it, the you of this hour, this minute, this second, something unexpected happens. You stop finding one of you. That is where we begin. Not with the universe, with the crowd wearing your name. Consider a single hour of your life. Any hour will do. Pick a good one. An afternoon from some summer years ago, or an evening that mattered, or nothing special at all. Just an ordinary hour in an ordinary week. Inside that hour, there was a person. That person thought things, noticed things, felt the chair underneath them and the light in the room. That person had your name, your memories up to that point, your whole past gathered behind them. And here is the important part. That person did not feel incomplete. They did not experience themselves as a fraction of somebody. Within that hour, they were all that they were, a full human being, entirely present, needing nothing from the future to finish them. Now do the arithmetic. If you have lived 25 years, you have lived through roughly 219,000 hours. Each one of those hours held a person like that, complete, self-contained, certain of being the whole of you. 219,000 of them. If you have lived 50 years, the number climbs past 438,000. A long human life of 80 years contains about 700,000 hours, which is to say, about 700,000 of those complete persons, each one convinced, correctly, that they were you. And the slicing does not have to stop at the hour. Cut finer. An 80-year life holds around 42 million minutes. It holds roughly 2.5 billion seconds. 2.5 billion, a number comparable to the count of heartbeats in a lifetime, which is not a coincidence, since the heart beats about once a second. Each of those seconds contained a you, not a partial you, a whole one. The you of any given second was not waiting to be completed by the you of the next second, any more than you, right now, feel like a preliminary sketch of the person you will be next Tuesday. As you listen to this sentence, you are not experiencing yourself as unfinished. You are simply you, entire, here. But that is exactly what every single one of those billions of previous selves would have said too. Let yourself see it. You are looking at one remembered hour of your own life, held up like a photograph. Then the photograph divides, gently, into 60 thinner frames, the minutes, and each frame is still a whole person, still you, still complete. Then each minute divides again into its 60 seconds, and the frames multiply into thousands, and you keep watching as the slicing continues, finer and finer, the crowd growing with every cut. Thousands of faces, and every face is yours. There is the you of one particular Tuesday morning, mid-yawn, thinking about coffee. There is the you of a specific second on a specific evening, listening to rain. None of them is a rough draft. None of them knows they are a slice. Each one sits at the exact center of its own moment, wearing the quiet certainty you are wearing right now, the certainty of being the one, the real, the present you. And every one of them was wrong about being the only one, or every one of them was right. That is the question. Hold it gently, and notice how strange it feels in the hand. There is a natural objection forming, and it deserves a hearing. Surely, you might say, those slices are not persons. They are just moments of one person. The you of that summer afternoon was a phase, not an individual. The person is the whole life, not the slice. That is a perfectly respectable position, and philosophers have defended it well. But notice what it costs. If the person is the whole life, then the person is something no one has ever experienced being. Nobody has ever felt themselves to be an 80-year object. Every feeling anyone has ever had was had by a slice. Whatever you are most certain of, that you are here, that you are you, that this moment is happening, that certainty belongs to a temporal sliver, and the whole life person you are appealing to is a construction assembled out of billions of slivers, none of which ever met each other. The slices are where all the living gets done. Dismissing them as mere phases means dismissing the only standpoint from which anything has ever been experienced at all. So here is the puzzle those thousands of selves force on us. What is the status of all those previous moments? Where are they? The you of 10 years ago felt every bit as real as the you of tonight. The certainty was identical. The presence was identical. If you had asked that person to prove they were real, they would have done exactly what you would do now, gesture at the world around them. There is an old story about the writer Samuel Johnson, who, upon hearing the philosophical argument that matter might not exist, walked over to a large stone and kicked it hard and said, "I refute it thus. That is everyone's proof of reality, in the end. Look, here, this. The you of a decade ago had a stone to kick too. Their this was just as solid as yours." The everyday answer is that those moments are gone. The past does not exist anymore. It happened, it finished, it vanished, and only the present survives. That is the common sense picture, and almost everyone on earth carries it without ever examining it. The moments of your life exist one at a time, like beads passing through a hand. Each bead is real only while it is being touched. The touched bead is called now. The others have either dissolved behind you or have not yet formed ahead of you. Reality, in this picture, is a single thin slice of existence, constantly being replaced. And yet the everyday answer has a crack in it that you can feel without any physics at all. If the past is simply gone, dissolved, non-existent, then what exactly is memory a memory of? When you recall that summer afternoon, your recollection claims to be about something, a real afternoon, with real light in it, that really occurred. A memory of a non-existent afternoon would not be a memory, it would be an invention. Our entire practice of remembering, of keeping promises made last year, of honoring people who died before we were born, treats the past as something withstanding, something that can make claims on us, something we can get right or wrong. We behave, in other words, as though past moments have not stopped being facts. They have only, somehow, stopped being here. Where the facts of the past reside, if they reside anywhere, is a question common sense has never had to answer. Physics, as we will see, was eventually forced to. But notice what that picture quietly assumes. It assumes there is a fact of the matter about which moment is the now. One slice of the universe's history that is lit up, currently happening, while all other slices are dark, and not just for you. For everything. For your street, for the far side of the earth, for the moon, for every star in every galaxy, all sharing one single universal present moment, all lit up together. When you glance at the night sky and think about what is happening on some distant world right now, you are using that assumption. It feels less like an assumption than like the obvious structure of reality itself. Of course there is a now. Of course it is the same now everywhere. What could it even mean for that to be false? That assumption has a name and a history, and for more than 2 centuries it sat at the very foundation of physics, endorsed by the greatest scientific authority who ever lived. It is also, and this is where our story truly starts, false. Not unfashionable, not oversimplified. False, in a way that has been demonstrated by experiment after experiment for over a century, and the demonstration is the doorway to the idea this whole night is about. Before we can walk through that doorway, though, we should pay our respects to the assumption itself, because the universal now was not a folk superstition. It was load-bearing architecture, installed at the foundation of science by Isaac Newton himself, and it worked so well for so long that almost nobody thought to check it. To understand what was lost, and what its loss did to those thousands of previous yous, you have to understand what the world looked like while everyone still believed in it. In 1687, Isaac Newton published the Principia, and in its opening pages, before a single law of motion, he paused to tell the reader what he meant by time. Absolute, true, and mathematical time, he wrote, of itself, and from its own nature, flows equably, without relation to anything external. Read that again slowly, because it is one of the most confident sentences in the history of science. Time flows on its own. It does not care about matter, about motion, about observers. It is a river running through the universe, at a perfectly steady rate, the same rate everywhere, and everything that happens in it. Newton's time came with a companion, absolute space, a fixed, universal stage on which all events play out. Together, they gave the universe something like a master ledger. Every event, a candle lit in London, a wave breaking on an unnamed shore, a comet rounding the sun, occupied one definite place and one definite instant in the ledger. And the ledger's pages turned at the same rate for everyone. Ask any question of the form, what is happening right now, anywhere in the cosmos, and the ledger had an answer. There was a fact about what the whole universe was doing at this very instant, a single frozen photograph of everything, and then the next photograph, and the next, flipping forward forever at one steady, universal rhythm. Notice how perfectly this matches the picture you carry in your own head. That is not an accident, and it is not because you read Newton. It is because Newton wrote down, with mathematical precision, the picture that human nervous systems generate automatically. We are built to assume a shared present. When you speak with someone, you assume your now and their now are the same now. When you think of a friend on another continent, you picture them doing something at this moment, sleeping probably, or pouring coffee, and the picture feels meaningful. Stretch it further. When you look up at the star Vega, 25 light-years away, you can ask what is happening there right now, tonight, and the question feels like it obviously has an answer, even if no one can know it. The universal present is not something we believe, so much as something we breathe. The 19th century even built its civilization around the assumption, quite literally. When railways began threading across continents, towns that had each kept their own local solar time, noon when the sun stood highest over your particular church steeple, suddenly needed to agree with towns hundreds of kilometers away, or the trains would collide. So the world invented standard time, then time zones, then, by the late 1800s, networks of telegraph wires carrying time signals between observatories, synchronizing clocks across oceans. It was one of the great engineering projects of the age, the construction of a single shared now, wrapped around the planet in copper wire. Nobody involved considered for a moment that they might be manufacturing something, rather than discovering it. The universal present was assumed to be out there, perfect and absolute, and the wires were merely distributing access to it, the way pipes distribute water that already exists. Keep this picture in mind, an entire civilization wiring itself together under the confident belief that right now is a fact of nature. The man who would demolish that belief spent his working days, in a fine historical irony, examining patent applications for exactly these devices, electrical schemes for synchronizing distant clocks, arriving on his desk in Bern by the dozen. And it worked. That deserves emphasis, because this is not a story about foolish people believing a silly thing. Newton's absolute time sat under 200 years of triumphant physics. It predicted the tides. It guided ships. It found the planet Neptune with pen and paper when astronomers noticed Uranus drifting off course, and calculated where an unseen world must be pulling it from, and looked, and there it was. A framework that can find a planet hiding in the dark 3 billion kilometers away has earned its confidence. By the late 1800s, physics built on absolute space and time seemed so complete that some physicists openly wondered whether their field was nearly finished, with nothing left but filling in decimal places. The strange thing is where the crack finally appeared. It did not come from the study of time at all. It came from the study of light, that everyday, ordinary brightness, and from a stubborn experimental fact that refused to fit the ledger. Throughout the 1880s and 90s, careful measurements kept showing that light in empty space always travels at exactly the same speed, about 300,000 kilometers per second, or in precise figures, 299,792,458 meters per second, the same speed no matter who measures it. The same for an observer standing still and an observer racing toward the light source at enormous speed. That last part is the impossible part. It is as if you drove your car toward an oncoming train, faster and faster, and the train kept approaching you at exactly the same rate, no matter what you did, as though your own motion simply did not count. For years, the best minds in physics tried to rescue the old picture, inventing ever more elaborate patches to explain the light measurements while keeping Newton's universal time intact. We have told part of that story on this channel before. The invisible ether that was supposed to carry light, and the famous experiment that failed to find it. The patches grew stranger and stranger. And then, in the spring of 1905, a 26-year-old examiner at the Swiss Patent Office in Bern decided to stop patching. His radical move was almost absurdly simple. Take the measurement at face value. Assume the speed of light really is the same for everyone, always. And then ask, with complete honesty, what must break to make that possible? What breaks is the ledger. What breaks is the single universal photograph of the present. What breaks, in other words, is the one assumption so obvious that in 2 centuries almost no one had thought to write it on the list of assumptions at all. It is worth being precise about why that light behavior and universal time cannot coexist, because the collision is not obvious at first glance. In Newton's world, speeds add. A ball thrown forward at 10 kilometers per hour from a train moving at 100 arrives at the ground observer as a ball moving at 110. Speed is relative bookkeeping, and the universal clock sits above it all, untouched. But if the speed of light refuses to participate in that bookkeeping, if the beam from the train's headlamp passes the ground observer at exactly the same speed it leaves the train, then something else must be flexing to absorb the difference. Speed is nothing but distance divided by time. If the speed cannot change, then distance and time must. The rigid ruler and the universal clock were the hidden currency in which all of Newton's bookkeeping was done, and the constancy of light quietly declared that currency counterfeit. One measurement, repeated and confirmed until denial became impossible, and the entire ledger, with its universal pages turning in step across the cosmos, was suddenly resting on nothing. Here is where we stand, then, at the threshold. On one side, the time of Newton and of your nervous system. One river, one rate, one universal now, the past dissolved, the future unformed, the present lit up, like a moving window, across all of existence. On the other side, a single stubborn fact about light. It does not seem like a fair fight. It seems like a technicality, the kind of thing specialists resolve in a footnote. But the young patent clerk followed the technicality with a kind of relentless, patient honesty, and what it destroyed was not a detail of the old picture. It was the centerpiece. The next part of our story is the argument itself, short, clean, and quietly devastating, and at its center is nothing more exotic than a train, a platform, and 2 bolts of lightning. The paper arrived at the journal Annalen der Physik in June of 1905, written by Albert Einstein, patent examiner, 3rd class. Its title gave no warning of what it contained. On the electrodynamics of moving bodies. There were no experiments in it. There was barely any advanced mathematics. Most of it is accessible to a good high school student. What it had instead were 2 assumptions, stated plainly, and then a willingness to follow them anywhere. The first assumption, the laws of physics are the same for everyone moving at constant speed, with no experiment able to reveal who is really moving and who is really at rest. The second, the speed of light in empty space is the same for every observer, regardless of their own motion. Every clock in the world was about to become negotiable because of those 2 sentences. To see why, Einstein offered a thought experiment of almost childlike simplicity, and it remains the cleanest way in. Picture a railway platform on an open plain, at night. A very long, very fast train is passing through without stopping. At the exact moment the middle of the train passes a person standing on the platform. Two bolts of lightning strike, one at the front of the train, one at the rear. The strikes scorch the rails, so there is no ambiguity about where they hit. Now ask a simple question. Did the two bolts strike at the same time? The person on the platform says yes, and their reasoning is impeccable. They are standing exactly halfway between the two scorch marks. Light from each strike travels toward them at the same speed. Light always does, over the same distance. The two flashes arrive at their eyes together. Same distance, same speed, simultaneous arrival. The strikes were simultaneous. Case closed. But there is a second observer, a passenger seated at the exact middle of the train. When the bolts strike, she is directly beside the person on the platform. The flashes begin their journey toward her too, but she is moving, gliding toward the place where the front bolt struck, and away from the place where the rear bolt struck. So the light from the front has slightly less distance to cover to reach her, and the light from the rear has slightly more. And here is the crucial point. The point the entire 20th century turns on. For her too, both flashes travel at exactly the same speed. That is the second assumption, the one experiment forced on us. Her motion does not add to or subtract from the speed of the light. So the flash from the front, covering less distance at the same speed, reaches her first. For the passenger, the front bolt struck before the rear bolt. Not appeared to strike first, struck first. Her measurement is as careful, as correct, as impeccable as the platform observers. Slow down and check the passenger's reasoning yourself, because the whole century turns on it, and it deserves more than one pass. Her situation, by the first assumption, is completely symmetrical with the platform observers. She is entitled to consider herself at rest. The theory insists on it. No experiment conducted inside the train, from bouncing a ball to timing a light beam, could ever reveal uniform motion. From her armchair, it is the platform that slides backward through the night. She notes that she sits exactly midway between the two scorch marks on the train. The marks are on her train, equidistant from her seat. Light from each strike crosses that equal distance toward her at the one speed light ever travels. The flash from the front arrives first. Therefore, she concludes, with the full authority of the same physics the platform observer used, the front bolt struck first. Every step is airtight. If you want to escape the conclusion, you must find the flaw. And there are only two candidate flaws. Either she is not entitled to treat herself as at rest, which would require a detectable absolute rest frame that a century of experiments has failed to find, or light does not travel at the same speed for her, which contradicts the measured fact the whole theory was built to honor. There is no third exit. The disagreement stands. So who is right? The person on the platform, who found the strikes simultaneous, or the passenger, who found that the front one came first? Newton's ledger demands a single answer. One universal instant either contains both strikes, or it does not. Einstein's answer was that the ledger does not exist. Both observers are right. Simultaneity is not a fact about the universe. It is a fact about a point of view. Whether two distant events happen at the same time has no absolute answer, any more than the question of whether the train is really moving and the platform really still. Each observer carries their own now, their own personal slicing of the world into past, present, and future, and the slicings do not agree. Sit with how strange that is, and notice that no trick has been played. Nobody's clock was broken. Nobody was fooled by travel delays of light. Both observers carefully accounted for those. The disagreement survives every correction because it is not an error. It is the structure of the world. The phrase "at the same time," applied to events in different places, turns out to be like the phrase "to the left of," useful, real, but meaningless without specifying to the left of whom, from where. The now, which Newton took to be a universal page of the cosmic ledger, is instead something each of us wears personally, like a shadow. You might wonder how large these disagreements are, and the honest answer is, at train speeds comically small. The effects scale with the ratio of the speed involved to the speed of light, and the speed of light is so enormous that everyday velocities barely register against it. A real train at 300 kilometers per hour is moving at about 1/3600,000th of the speed of light. The simultaneity disagreements it generates across a platform are measured in fractions of a trillionth of a second. This is why 20 centuries of careful human observation never noticed. The old picture was not foolish. It was the correct approximation for every speed any human had ever traveled. But an approximation is a different kind of thing from a truth, and the gap between them, however small, is a wedge. Push the speed higher, and the wedge opens. At half the speed of light, clocks disagree by 15%. At 99%, a moving clock ticks 7 times slow. At 99.999%, more than 200 times slow. The universe permits these speeds. Its particles reach them routinely, as we are about to see. And at those speeds, the negotiability of time stops being a curiosity and becomes the dominant fact of existence. The consequences cascade quickly, and Einstein traced them within that same short paper. If observers disagree about simultaneity, they must also disagree about durations. A moving clock, checked against a row of synchronized stationary clocks, runs slow. Not because of any mechanical fault, but because time itself elapses differently along different paths through the world. This is time dilation, and we have explored it before on this channel. How it stretches, how it has been confirmed again and again. Moving rulers shrink along their direction of motion. Speeds refuse to add the way common sense insists. Each effect follows from the two assumptions, as inevitably as checkmate follows from a blunder, and each has been measured in the century since, to precision after precision, and the measurements are the subject of the next part of our journey. But before the evidence, pause on what has already happened, here, in the argument itself, because this is the first crack in the wall, and everything else tonight comes pouring through it. If there is no universal now, then the universe cannot be the thing common sense says it is. A single three-dimensional scene, existing in the present, being continuously replaced. There is no one present to exist in. The passenger and the platform observer, passing within arm's reach of each other, carve the universe into now and not yet along different angles. And both carvings are correct. Two people, 1 meter apart, and reality declines to say which of their nows is the real one. It declines, we will see, because it must. Picking one would mean picking a preferred frame of reference, a secretly correct answer to who is really at rest, and the entire structure of relativity, confirmed now by more than a century of experiment, is built on there being no such answer. The now cannot be saved by better instruments or cleverer definitions. It is not hiding. It is simply not there. Of course, a thought experiment about trains and lightning could be dismissed as philosophy with props. In 1905, that is roughly how much of the physics establishment treated it. What could not be dismissed was what happened over the following century, as the technology to test these claims arrived, and every single test, from particles raining out of the sky, to clocks flown around the world in passenger jets, to the satellite network currently orbiting above your roof, came back with the same verdict. The strange time of the patent clerk is the real one. The comfortable time of Newton and of your nervous system is the approximation. Let us look at the evidence, because it is not locked in laboratories. Some of it is in your pocket. High above your head, right now, cosmic rays are slamming into the upper atmosphere. Each collision, about 15 kilometers up, sprays out a shower of short-lived particles, and among them is one called the muon, a heavy cousin of the electron, with a lifespan so brief it barely deserves the word. At rest, a muon survives for about 2.2 microseconds, 2.2 millionths of a second, before it falls apart. Even traveling at nearly the speed of light, a particle with that lifespan should cover only about 660 meters before decaying. From 15 kilometers up, essentially none of them should ever reach the ground. It would be like expecting a snowflake to survive a fall into a furnace. And yet they arrive. In enormous numbers. Muons are passing through the ceiling above you as you listen to this. Several of them will pass through your body every minute of your life. In 1963, two physicists, David Frisch and James Smith, counted them properly, comparing the muon rate at the top of Mount Washington in New Hampshire with the rate near sea level, and the numbers said something unambiguous. Far more muons survive the trip than their lifespan should allow. The resolution is Einstein's. The muons are moving so fast that their internal time runs slow from our point of view. Their 2.2 microseconds, stretched by speed, spans the whole journey. Time dilation is not a metaphor for them. It is why they exist long enough to reach us. Every muon that lands is a small, silent confirmation that time is not universal, delivered continuously, everywhere on Earth, for free. There is a detail in the muon story worth savoring, because it shows the symmetry of the thing. From our point of view, the muon survives because its time runs slow. Its 2.2 microseconds are stretched to cover the journey. But the muon, if it could reason, would tell a different and equally correct story. In the muon's frame, its lifespan is a perfectly ordinary 2.2 microseconds, unstretched, and it is the mountain of atmosphere that is moving, rushing upward past it at nearly the speed of light. Moving objects contract along their direction of motion, so for the muon, those 15 kilometers of sky squash down to a few hundred meters, a distance its short life crosses with ease. Two observers, two accounts, time dilation for us, length contraction for the muon, and one shared, agreed-upon outcome: the particle reaches the ground. This is the theory's deep consistency on display. Space and time adjust in tandem, frame by frame, precisely so that events, the actual meetings and arrivals and collisions, the things that happen, come out the same for everyone. What no observer anywhere can construct from any of it is a shared universal now. The events agree, the nows never do. Perhaps particles feel too distant. Then consider clocks. Actual, physical clocks. In October of 1971, two American scientists, Joseph Hafele and Richard Keating, did something so simple it sounds like a prank. They bought airline seats for 4 atomic clocks. They flew them around the world, first eastward, then westward, on ordinary commercial flights, and afterward compared them with the reference clocks that had stayed behind at the United States Naval Observatory in Washington. If time were Newton's universal river, the traveling clocks and the stay-at-home clocks would agree to the nanosecond. They did not agree. The flown clocks differed from the grounded ones by tens to hundreds of nanoseconds, tiny intervals, but enormous compared to the accuracy of atomic clocks, and the differences matched the predictions of relativity. The clocks that took different paths through the world simply experienced different amounts of time. Both were running perfectly. There was no correct clock to appeal to, because there is no master time for either of them to be measuring. And then there is the confirmation you own. Orbiting about 20,200 kilometers above the Earth is a constellation of satellites, each carrying atomic clocks, each continuously broadcasting the time. Your phone finds your position by comparing those broadcasts. Timing, essentially, is the entire trick. But the satellite clocks do not tick at your rate. Their orbital speed slows them by about 7 microseconds per day. The weaker gravity at their altitude, an effect of general relativity, Einstein's later and larger theory, speeds them up by about 45 microseconds per day. The net result: the clocks overhead run fast by about 38 microseconds, 38 millionths of a second, every single day. That sounds like nothing. It is not nothing, because the system works by timing light speed signals. An uncorrected drift of 38 microseconds daily would smear your position by roughly 10 kilometers each day. Within a week, your navigation would place you in a different town. The engineers who designed the system knew this, and built the corrections in from the start. Which means something worth saying slowly. Every time your phone quietly draws that blue dot on a map, it is compensating for the fact that time up there and time down here genuinely disagree. Relativity is not exotic. It is infrastructure. It helps to appreciate what an atomic clock actually is, to feel the force of those flown clock results. A cesium atomic clock keeps time by counting the oscillations of microwave radiation absorbed and emitted by cesium atoms. 9,192,631,770 oscillations by definition per second. The definition of the second itself, since 1967, is that count. These are not fine watches that might run fast on a bumpy flight. They are devices that tie timekeeping directly to the unchanging behavior of atoms, stable to parts in 100 trillion. When two such clocks disagree, after one travels and one stays, the disagreement is not error, it is a measurement, arguably the purest measurement there is, of the amount of time each path through the world actually contained. Hathaway and Keating's airline tickets, famously cheap as physics experiments go, bought one of the most philosophically expensive results in history: direct instrumental proof that duration is a property of the route you take, like mileage, and not a universal backdrop ticking behind all routes equally. Take a breath here, because the quiet implication of these experiments matters more than their cleverness. The muons, the flown clocks, the satellites, they are not just confirming that clocks misbehave at high speed. They are confirming the picture that made the strange predictions in the first place. The picture with no universal now in it. The disagreements are not illusions layered on top of a true universal time. There is no experiment, anywhere, in more than 100 years of increasingly desperate ingenuity, that has caught a glimpse of Newton's river behind the relativistic effects. The effects go all the way down. Different paths through the world contain different amounts of time, and no path holds the master copy. Now, an honest person will notice the sizes of these numbers and feel reassured. Microseconds, nanoseconds, 38 parts in a day of 86 billion microsecond parts. Yes, the universal now is technically broken, but barely, surely. At walking speeds, at human distances, the disagreement between your now and mine is so small that no instrument on Earth could find it. Does a discrepancy that small really deserve to overturn the way we picture reality? It is a fair question, and it contains a hidden assumption of its own, that a tiny effect stays tiny. But look again at the simultaneity offset from Einstein's train. Its size depends on two things: how fast the observers move relative to each other, and how far away the events are. Velocity is one lever, distance is the other, and distance, in this universe, is a lever with essentially no end to its length. So far we have only pulled the velocity lever, and only gently, airliners, satellites, particles. The now barely trembled. In the next part, we leave the velocity lever almost alone. We will move at a stroll, the slowest speed in this entire story, and we will pull the distance lever instead, out past the moon, past every star you have ever seen, to a smudge of light 2.5 million light-years away. At that distance, watch what a walking pace does to the present moment. The now does not tremble, it swings by days. There is a galaxy you can see with your bare eyes, if the night is dark enough and you know where to look. It sits in the constellation Andromeda, a faint, elongated smudge, easy to mistake for a wisp of cloud. That smudge is the combined light of roughly 1 trillion stars, and it is the most distant thing human eyes can see unaided, about 2.5 million light-years away. The light arriving at your retina left it before our species existed. For our purposes tonight, Andromeda is not the destination. It is the far end of a lever, the distance lever, and we are about to rest one finger on it, gently, at a walking pace. Recall the rule from Einstein's train. Two observers in relative motion slice the universe into past, present, and future, along slightly different angles. The size of the disagreement grows with the distance to the events in question. The formula is simple: the velocity multiplied by the distance divided by the speed of light squared, and the speed of light squared is a gigantic number, which is why, for nearby events, the disagreement is hopelessly small. Two people jogging past each other disagree about what is happening right now across town, by an amount trillions of times too small to notice. Common sense survives at human distances, but the formula has that other factor in it: distance. Feed it a bigger separation, and the same tiny velocity buys a bigger disagreement. Feed it 2.5 million light-years, and something extraordinary happens. Picture it. The night is clear and still, and a quiet street runs along the edge of a town. Andromeda is up, a pale thumbprint above the rooftops. Two strangers are out walking. One walks north, the direction beneath that far galaxy. The other walks south, away from it. They approach each other on the same stretch of pavement, unhurried, hands in pockets, and for one moment they are side by side, close enough to nod, close enough to share the cold air. Nothing happens. Shoes on pavement, two exhaled breaths fogging in the dark, and they pass. But stretch that moment out, and follow each of their nows across the sky. Each stranger's motion tilts their personal slice of the universe, and across 2.5 million light-years, the tilt opens like a fan. As they pass, in the seconds their shoulders draw level and separate. Their two versions of what is happening right now in Andromeda sweep apart by roughly a week. For the walker heading toward the galaxy, this instant over there contains events the other walkers this instant will not contain for days. Somewhere in that spiral of 1 trillion stars, there are whole worlds of happenings. Storms on unnamed planets, stars collapsing, perhaps beings deciding things, that sit inside one stranger's present and outside the other's, and neither stranger feels a thing. They continue up the street, two small figures under the streetlights, each carrying a different universe of now, both of them right. Be careful to hear what is and is not being claimed on that sidewalk, because this is a place where misunderstanding comes easily. Neither walker sees anything different in Andromeda. Both are receiving the same 2.5 million-year-old light. Neither can use the effect to learn tomorrow's news from the galaxy, or to send a message into its past. The light cones forbid it absolutely, and nothing in this story ever violates them. The claim is quieter and stranger than that. Simultaneity, the assignment of which distant events share this present moment, is part of an observer's coordinate description of the world, and the two walkers' descriptions, both flawless, both fully licensed by the physics, differ at Andromeda's distance by days. If now were a physical fact, their descriptions could not both be right. They are both right. So now is not a physical fact. It is perspective, rendered with such conviction by every nervous system that humanity mistook it for architecture. Run the numbers, and the poetry checks out. A walking pace is about 1.4 meters per second. Multiply by the distance to Andromeda, divide by the speed of light squared, and the shift in simultaneity comes out to roughly 370,000 seconds, a little over 4 days. Each walker is shifted about 4 days from the other, in opposite directions, so the gap between their two nows at Andromeda spans more than a week. No rockets, no particle accelerators. The most ordinary human activity there is, walking, is enough to swing the present moment of a distant galaxy by days. The now, which held perfectly rigid across your whole neighborhood, turns out to be soft, and the softness was merely hiding in the distance. This scenario has a name in the literature, the Andromeda Paradox, and in the 1960s, two thinkers independently realized that it is not just a curiosity, it is an argument, maybe the sharpest argument in all of physics about what reality is. In 1966, A Dutch physicist named C.W. Reitdijk published a proof built on exactly this setup, and a year later, in 1967, the American philosopher Hilary Putnam published his own version, titled Time and Physical Geometry. Their shared reasoning runs like this. Suppose you insist, with common sense, that what is real is what exists now. Then ask, whose now? The walker heading north has a now that includes, say, a particular event in Andromeda, call it the storm. The walker heading south has a now in which the storm is still days in the future, not yet real, still open. But both walkers are standing at the same place at the same moment, and neither has any privileged claim. Relativity guarantees that absolutely. You cannot say the northbound walker's slice is correct, and the southbound walker's is an error. The whole content of the theory is that no frame is the true one. So follow the logic where it insists on going. If the storm is real in one valid now, and every valid now has equal standing, then the storm is real, even for the walker whose now places it days in the future. What one observer calls the not yet, another equally valid observer calls the already. And you can chain the argument onward. For an observer out near the storm, moving just so, events on Earth days ahead of our walkers sit in the present slice. Every event, anywhere in space, at any point in the past or future, lies in the valid now of some possible observer. If being in a valid now is what makes something real, then everything is. Every event that has ever happened, and every event that ever will, all of it, equally, simply real. Putnam ended his paper with a sentence philosophers still argue about. The problem of the reality of future events, he declared, was now solved by physics. Philosophers have spent 6 decades trying to blunt the Reitdijk-Putnam argument, and the attempts are instructive precisely because of how they fail. One response says, fine, then let reality be relative too. Let each observer have their own catalogue of what exists. But a reality that differs between two people passing on a sidewalk has given up the very thing the word reality was for. Existence is not supposed to be a matter of opinion. Another response says, simultaneity is a mere convention, so nothing real hangs on it. But that concedes the conclusion rather than escaping it. If there is no fact about which distant events are present, then presentness cannot be what confers existence, and the common-sense picture collapses just the same. The argument is less like a trap than like a turnstile. You can push against it from several angles, but every angle turns you into the same room. The room is the one where all events, everywhere, at every time, stand on equal footing, and we are now standing in it. Notice what has quietly happened tonight, to you. In part 2, you met the thousands of previous versions of yourself and asked, uneasily, where they went. Common sense answered, they are gone. Only the present one exists. But we have now watched that answer's foundation, the single universal present, fail on a quiet street at a walking pace. If there is no fact about which slice of the universe is now, there is no fact that could make one slice of your life the only real one. The logic that keeps the storm in Andromeda real keeps the you of 10 years ago real. All those selves, every one of them certain of being the whole of you. Perhaps none of them ever stopped existing. Perhaps they are all still there, each at its own location in time, the way every town on the map is still there after you have driven through. There is a picture of reality in which that sentence is not poetry, but plain description. The picture Einstein's own teacher unveiled to a hall of scientists in 1908, with one of the most dramatic opening lines ever spoken at a scientific conference. It has a name. It is the idea this entire night has been building toward, and it is time, at last, to say it out loud. Let us step back first, and stack the pieces, in order, because you have earned the full view. We began with a question nobody can answer. What is time? And noticed that a human life, examined closely, dissolves into thousands of complete momentary selves, whose reality is hard to deny and hard to place. We met the assumption that props up the common sense answer, Newton's universal now, one cosmic present shared by all things. Then 1905 arrived. Einstein took the constancy of the speed of light seriously, and simultaneity shattered into private slices. The train and the platform, each correct, each carving a different now. The muons, the flown clocks, and the satellites over your roof confirmed that this is how the world actually works. And finally, on a dark street under Andromeda, we watched two strollers swing the present moment of a galaxy by a week, and followed Rietdijk and Putnam to the conclusion the mathematics had been holding out to us all along. If every valid now has equal standing, then all events, past, present, and future, are equally real. Now the idea, plainly. If all events are equally real, then the universe is not a three-dimensional scene unfolding in time. It is a four-dimensional object, 3 dimensions of space and 1 of time, fused into a single fixed structure containing every event that has ever happened and every event that ever will. Nothing comes into being, nothing passes away. The universe does not happen. It simply is, whole, complete, all at once, if those words even apply to something that contains time rather than sitting inside it. Physicists call this picture the block universe, and the sentence at its center, the one this whole night exists to earn, is this: time does not flow through the universe. Time is laid out inside it, like space. That is the idea. If you do not understand it, you do not understand physics as physicists actually have it. And if you do understand it, truly, all the way down, it changes the meaning of every moment you have ever lived. The picture deserves to be seen, not just stated. So look, you are floating in darkness, and before you hangs an immense solid of smoked glass, not a cube exactly, more like a slab without visible edges, extending away farther than you can follow. One of its directions is time. Lean closer, and the glass is not empty. It is threaded, everywhere, with fine luminous filaments, billions upon billions of them, like hair-thin rivers of light frozen mid-current. Each thread is a world line, the complete history of one thing, drawn as a single strand. Short, bright threads, particles that lived for a millionth of a second. Long, patient cables, stars, burning for 10 billion years. Here is a braid that is the Earth, wound around the thicker cable of the sun. And there, lean closer still, is a thread that concerns you. It begins at a hospital, decades ago as you would say, one end, woven from the threads of two parents. Follow it. Every moment of your life is here, not as memory, but as geometry. The summer afternoons, the person you loved, the hour you have been listening to this voice, all of it present in the glass, each moment at its own address, none of them glowing brighter than the rest. There is no dot sliding along the thread to mark where you are. The thread does not need one. Every point on it is a you, at its own moment, each one certain, it is the present one. You looked for the crowd of your past selves once tonight. Here they are. They were never gone. They are simply elsewhere in the block. Stay in the glass a moment longer, because there is a detail that repays attention. Find any place where two threads meet, a conversation, a handshake, a collision of particles. Notice that the meeting is not an event that occurs to the threads. It is a place where the threads touch, a junction in the weave, as fixed and structural as the crossing of two roads. Every meeting you have ever had is such a junction. Every parting is a place where threads that ran parallel begin to diverge. From inside a life, meetings and partings feel like happenings, things that come at you out of the future and recede into the past. From the vantage of the glass, they are features of the pattern, the way a knot is a feature of a carpet. And one more detail, easy to miss. The block has no thread for the now. Search the whole structure. You will find world lines for every particle, every photon, every person, but nowhere a golden filament marking the present, sweeping along the time direction like a tide line. The threads are all there is. The tide line, if it exists at all, is not in the glass. This picture entered physics through a lecture hall in Cologne on September 21st, 1908. The speaker was Hermann Minkowski, a mathematician of formidable reputation who, years earlier in Zurich, had taught mathematics to a student named Albert Einstein and had privately considered him a lazy dog who never bothered with mathematics at all. Now the lazy dog had rewritten physics, and Minkowski had seen something in the equations that even Einstein had not yet fully seen. The theory was not really about trains and clocks and rulers. It was about geometry. Space and time were not two things affected by motion. They were two shadows of one thing, a four-dimensional continuum in which each observer's motion simply determines the angle at which they slice it into a space and a time. Minkowski opened his lecture with a sentence he knew would outlive him, and it has. "The views of space and time which I wish to lay before you," he told the audience, "have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth space by itself, and time by itself, are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." Einstein resisted the geometric turn at first. He reportedly grumbled that since the mathematicians had invaded the theory of relativity, he did not understand it himself anymore. Then he understood it better than anyone, and built his theory of gravity on it, and never let it go. What Minkowski's geometry does to time is worth saying carefully, because it is the exact center of tonight's idea. In the block, time has become a direction. Your world line extends along it the way a road extends north. The you of last Tuesday is not a ghost. It is you. A little farther down the road, the way the town behind you on a highway is not an abolished town. Physicists call this move the spatialization of time. Earlier and later become locations, like east and west, rather than a vanished past and an unborn future. The hall in Cologne heard time described as a dimension, and within a few years, physics stopped being able to describe it any other way. Every relativistic calculation since, including the ones that keep your phone's blue dot honest, is a calculation inside Minkowski's block. It is fair to ask whether the block is really forced on us or merely suggested, and the honest answer is that it is the reading the physics most naturally supports, resisted mainly at a price. Minkowski's geometry is, first of all, the working language of the field. When physicists compute anything relativistic, the correction for a satellite, the decay of a flying muon, the collision of two black holes, they compute inside the four-dimensional structure, treating past-directed and future-directed intervals with even hands. The formalism never asks which slice is present, and never needs to. One can decorate the block with a preferred moving now, and change no prediction, but a decoration that changes no prediction is exactly what physics has learned, painfully and repeatedly, to shave away. The universe behaves in every measured respect, as the block says it should. Whether it also is what the block says it is, that is the question the rest of tonight will keep sharpening rather than settling, and it is only honest to mark the difference now. The mathematician Hermann Minkowski, one of the profound minds of that generation, stated the conclusion with a clarity that still unsettles physicists a century later. "The objective world simply is," he wrote. "It does not happen. Only to the gaze of my consciousness, crawling upward along the lifeline of my body, does a section of this world come to life as a fleeting image." Read that as a description of the glass block, and it is almost gentle. The block does not happen. Nothing in it moves, because motion is already drawn in. Motion is just the shape of a thread. What we call the passage of time, Whale is suggesting, is not out there in the world at all. It is something about the crawling gaze, about you. Keep Whale's phrase near. We will need it again before the end, because it contains, folded up, both the idea's triumph and the idea's wound. And if you want to know whether the people who built this picture actually believed it, believed it where it counts. In the hard moments of a human life, there is a letter. In March of 1955, Michele Besso died in Geneva. Besso was Einstein's closest friend, and had been for more than 50 years, his sounding board at the patent office in the miracle year of 1905, the only person Einstein thanked in that first relativity paper, his companion through 2 world wars, 2 marriages, a whole century turning over. Einstein was too frail to travel to the funeral. Instead, he wrote to Besso's family, and near the end of the letter, this: "Now he has departed from this strange world a little ahead of me. That signifies nothing. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." He was not reaching for a pretty phrase. He was stating the physics he had spent his life confirming. In the block, Besso's thread does not end so much as it lies complete. Every year of the friendship as real as ever, back down the time direction, at its own address in the glass. A little ahead of me. Einstein followed within weeks. He died that April, and the 2 threads lie side by side in the structure to this day, as they always will. It is the most beautiful consolation physics has ever offered anyone. Whether it is a true consolation, whether the block deserves to be believed all the way down to the deathbed, depends on questions we have not yet faced. Because you may have noticed something missing from the glass. You may have noticed that everything tonight has been leading you into a picture of time with no flow in it, no passage, no moving now, while every second you spent listening, time, for you, went right on flowing. The block is beautiful. The block is supported by every experiment ever run, and the block looks nothing like the inside of your life. That collision is not a detail, and physicists know it is not a detail. Before we face it, though, we should be fair to the block, because there are 2 things everyone fears it destroys, and it destroys neither. The block does not make the universe an undifferentiated frozen soup, and it does not make you a puppet. The glass has a grain to it, a structure of before and after that survives everything. That structure is the light cone, and it is the most underappreciated piece of architecture in all of physics. A reasonable person, meeting the block universe for the first time, tends to have 2 reactions in quick succession. The first, if past and future are equally real, then surely anything goes. Surely the distinction between cause and effect, before and after, collapses into mush. The second, if my future already sits in the glass, then my choices are theatre, and I am a passenger in my own life. Both reactions are natural, both are wrong, and seeing why they are wrong is part of understanding the idea. The block that physics actually describes is a far more structured, far less nihilistic object than the one people fear. Start with the structure. When Minkowski fused space and time, he did not blend them into an indistinguishable porridge. Time enters the geometry with a different sign, a minus where space carries a plus, and that one minus sign builds an architecture into every point of the block. From any event, say, the snap of your fingers, here, now. Light spreading outward at its fixed speed traces a widening sphere, drawn in space-time, with time running upward. That sphere becomes a cone, opening toward the future. Mirror it downward, and you get a second cone, all the light that could have arrived at your finger snap from the past. Physicists call this double funnel the light cone, and every event in the universe wears one. It is not an add-on to the block. It is the grain of the glass itself. Give the cone a human scale before we use it, because it is easy to picture wrongly. Light travels about 300,000 kilometers in a second, 7.5 times around the Earth. So the future light cone of your finger snap, 1 second after the snap, is already a sphere of possibility, 300,000 kilometers across, swallowing the moon's orbit in under 2 seconds. On everyday scales, the cones are so wide open that everything on Earth is effectively inside everything else's cone within a blink, which is why daily life never notices them. Stretch to the cosmos, and the cones become the strictest law there is. The sun could vanish this instant. permitted a moment's impossibility for the sake of the point, and no consequence of any kind, not even gravity's change, could touch the Earth for the 8 minutes and 20 seconds light takes to cross the distance. Your fingersnap's influence, expanding forever at the speed of light, will not reach the nearest star for more than 4 years, or Andromeda for 2.5 million. The cone is not a metaphor. It is the exact agreed-upon boundary of what any event can ever matter to. The cone sorts every other event in the universe into 3 classes, relative to your fingersnap. Events inside the future cone are reachable: a signal, an influence, a person traveling from here and now could get there. Events inside the past cone could have reached you. And events outside both cones, the enormous elsewhere, can neither touch you nor be touched by you, because doing so would require crossing space faster than light. Here is the remarkable fact. While observers disagree about simultaneity, about durations, about lengths, about all the things Newton thought absolute, every observer in the universe, whatever their motion, agrees exactly on the light cones. The train passenger and the platform observer draw identical cones. Which events can influence which is not a matter of perspective. Causal order, for events that can be causally connected at all, is absolute. If your fingersnap could have caused something, every observer agrees the snap came first. So the block is not mush. It is more like wood than glass, now that you look closely. Grained through and through, every thread of every world line confined to climb within its own nested sequence of cones. No influence ever leaking sideways into the elsewhere. The universe does not need a global now to keep cause ahead of effect. The cones do that locally, everywhere, unanimously. And this is why physicists can live inside the block without vertigo. The relations that make science possible, this caused that, this came before that, along every connected path, survive perfectly. What failed was never causality. What failed was only the idea that the universe agrees on a single simultaneous present, spanning the elsewhere. Order held, the now dissolved. And it turns out, order never needed the now. Now the second fear, the one that reaches closer to the bone. If the block contains your future, complete and fixed, are you free? Some popular accounts state it bluntly. Relativity proves your future is already written, so nothing you do matters. You will hear this claim online, often presented with a kind of grim satisfaction. But listen to what it actually assumes. Already written. Written by whom? Before you made your choices? The block contains no before its own contents. It is not a prophecy composed in advance of your life. It is your life. The future portion of your world line is not a script handed to you. It is the 4-dimensional shape of what you do. If at some moment down the time direction you choose the harder kindness or the braver path, then that choice is what sits in the block at that address, and it sits there because you make it. Remove the choice, and you remove the content. The block no more bypasses your deciding than a finished biography bypasses the living of the life it records. Whether human choices are free in the deepest metaphysical sense is a real question, but it is the old question of determinism, and it stands exactly where it stood before relativity. The block picture adds nothing to it and subtracts nothing from it. Eternalism, as philosophers call the block view, is a claim about when things are real, not about whether you are the author of your portion of the glass. There is even a sense in which the block treats the anxious question about the future unfairly gently. People fear that a real future means a fated future, that somewhere ahead on the thread, outcomes are waiting for them like furniture in a dark room. But symmetry deserves its say. The block also contains your past, and no one feels fated by that. The you of this evening was once the wide-open future of the you of 10 years ago, unformed, unwritten, anything possible. That earlier self worried, planned, chose, and the choosing produced the thread that now runs between you. Nothing about the threads existing in the 4-dimensional structure reached back and did that earlier self's living for them. The same relation, and nothing more, holds between tonight's you and the selves farther up the time direction. They are not waiting for you like furniture. They are what your choosing amounts to, seen from an angle no human ever occupies. Fate is a story about being overridden. The block contains no overriding, only lives, whole, with the deciding woven in at every millimeter. It is worth pausing on how strange and how sturdy this combination is, because it is the mature form of tonight's idea. All moments real, no universal present, and yet perfect causal order, agreed on by everyone, your biography authored by you, the muons still decaying on schedule, the satellites still needing their 38 microseconds of correction each day. The block is not a fever dream bolted onto physics. It is physics, doing exactly what it has always done, keeping every appointment, honoring every measurement, while quietly declining to contain the one thing the human mind keeps insisting on. Nothing in the cones, nothing in the grain, nothing anywhere in the geometry marks a present moment, or pushes anything from past to future. The architecture is complete, and the architecture is still. And so we arrive, prepared now, at the wound. We have given the block every courtesy, seen its evidence, admired its grain, acquitted it of fatalism. The picture stands. And yet you, the actual you, in the actual dark, listening, did not experience this last hour as a completed segment of thread in a glass solid. You experienced it happening, one sentence at a time, arriving and dissolving, carried on something that felt exactly like a current. The block says, there is no current. Your whole life says, there is. In the next part, we walk straight into that contradiction, into a static stretch of your own world line, searching it for the one thing the geometry cannot seem to hold. And we meet the question Stephen Hawking asked about it, the question that may be the deepest one left in physics. Return to the glass block one more time, but now with a different purpose. Before, we toured it. This time, we are searching it. The claim on the table is that this static object is the whole of reality, that everything true about the universe, including everything true about you, is somewhere in the glass. Very well. Then somewhere in the glass, there should be the most familiar fact of your existence, the fact that time passes. Let us go and find it. Drift down to your own thread and choose a stretch of it, a single centimeter of world line, which at the scale we are imagining might span a few seconds of your life. Pick the few seconds, some evening long ago, in which you once said the words, "I'm glad you're here," to someone who mattered. Magnify the stretch. Look inside. Everything is present, and the detail is absolute. Here are the two threads, yours and theirs, running close and parallel. Here is the fine structure of the moment, rendered as pure geometry. The air between you corrugated with pressure ridges, those are the sound waves of your voice, hanging in the block like ripples carved in stone. Here is the exact configuration of your face, and a few millimeters up the time direction, the next configuration, the smile slightly further along, the way adjacent frames of a film strip differ. Your heartbeat is a tidy periodic waver in the thread. The warmth of the room, the lamplight, the catch in your breath before you spoke, all of it is here, every physical fact, arrayed along the time direction in perfect order. Now search this scene of you speaking, mid-word, mid-feeling, for the happening. Find the part where the moment occurs. Look for anything in the geometry that singles out one slice as the live one, anything that moves, anything that carries the voice forward from one syllable into the next. Take your time. There is nothing. The syllables do not sound one after another. They simply sit at successive addresses. The smile does not spread. It merely varies along an axis. Nothing in this centimeter of glass is happening, any more than the leftmost stripe of a painted rainbow is happening. It is a configuration. It is complete. It is utterly still. And it is supposed to be you, in one of the most alive seconds you ever had. Stephen Hawking, a man who spent his career inside these equations and trusted them as far as anyone alive, put a question to this stillness in his book, A Brief History of Time, in 1988, and it has never been answered. Even if there is only one possible unified theory, he wrote, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Hold that phrase against the frozen conversation in the glass. The equations describe the pressure ridges, the configurations, the whole geometry, flawlessly. What they do not contain is the fire, the burning forward of the moment, the fact that for you, that second was not an address, but an event, arriving out of an open future and igniting into presence and slipping into a fixed past, all in the time it took to say 5 words. The block holds the shape of your life. It does not seem to hold the living of it. And physics, which can calculate the first 3 minutes of the universe and the last light of black holes, has no equation, none, anywhere, in any theory, whose terms mean, and then the moment actually occurs. Perhaps you might think the stillness is an artifact of the imagery. Perhaps a glass block was always going to look frozen and a fairer picture would move. But try to build the fairer picture and watch what happens. Suppose we grant the block a moving now, a luminous sheet sweeping along the time direction, lighting each slice in turn, the cosmic projector lamp that turns the film strip into a film. Ask the innocent question, how fast does the sheet sweep? The only available answer is 1 second per second. It advances 1 second of time per second of time. But that is not a rate, it is a ratio of a thing to itself, true of any sheet moving at any pace, true of no sheet at all. A speed needs to compare one quantity against a different one, meters against seconds, degrees against minutes. The now's motion has nothing external to be measured against, because time was the measuring stick, and the now is supposed to be moving along the stick itself. Press harder, and a second embarrassment appears. For the sheet's sweep to be an event, a happening, it would seem to need its own time to happen in, a second time, behind time, in which the first time's present does its moving, and then a third behind that, forever. The moving now is not merely absent from the equations. Stated carefully, it struggles to be a coherent idea at all, and yet it remains the single most vivid feature of being alive. That is the genuine depth of the problem. Not that physics forgot something obvious, but that the obvious thing resists every attempt to say it clearly. Be precise about what is missing, because it is not one thing, but 3, braided together. First, the now. Experience insists that one moment is lit up, special, present, while the equations treat every moment identically, and relativity denies that any global slice could be the lit one. Second, the flow. Experience insists that time moves, that the lit moment travels futureward, while the block contains no motion, and worse, the very idea is hard to state without stumbling, for if the now moves, how fast does it move? 1 second per second? Is that a speed or a tautology? Third, the openness. Experience insists the past is fixed and the future is not yet settled, while the geometry holds both directions of the time axis with the same even grip, and the fundamental laws themselves are almost perfectly time-symmetric, running as happily backward as forward. Yes, entropy increases, disorder piles up futureward, and that thermodynamic gradient is real and important, and we have devoted a whole night to it before. But look closely. A gradient is a direction, not a current. The block can contain an entropy slope the way a mountainside contains a slope, without anything sliding down it. An arrow painted on a frozen river points somewhere. It does not make the water move. So the situation is this, and it deserves to be stated with the discomfort it has earned. The most successful theory of space and time ever constructed, verified by the muon rain, by flown clocks, by the satellites correcting themselves over your roof at this moment, describes a universe in which nothing passes, nothing flows, and no moment is now. And the one witness who contradicts it is every conscious being who has ever lived. This is not a fringe puzzle. Einstein himself carried it like a stone in his pocket. The philosopher Rudolf Carnap recorded that Einstein told him the problem of the now worried him seriously. The experience of the present, Einstein said, means something special for man, something essentially different from the past and the future. And yet this important difference does not and cannot occur within physics. That this experience cannot be grasped by science seemed to him, Carnap wrote, a matter of painful but inevitable resignation. The man who dissolved the universal now, the man who consoled a grieving family with the block itself, privately conceding that the thing his theory could not capture might be the most important thing there is. Where, then, could the fire live? Only two directions remain, and the rest of tonight walks them both. Either the fire is in the world, passage is real, the block picture is incomplete, and physics is missing a piece of reality itself. Or the fire is in the witness, the block is the whole truth, and the flowing now is something your mind builds, a rendering, the way color is a rendering of wavelength. That second road leads somewhere unexpected, not out into the galaxy, but inward, to the strange fact that your awareness occupies only a sliver of your world line at a time, a window a fraction of a second wide, crawling, as Whale said, along the lifeline of your body. Why a sliver? Why that width? Why a crawl at all? Follow those questions and the deepest problem in physics quietly joins hands with the deepest problem about the mind. That meeting place, the 50-millisecond window through which you have experienced everything you have ever experienced, is where we go next. Here is a fact about you so constant that you have never once observed it, the way a fish never observes water. You have never experienced your life. You have only ever experienced a sliver of it, one thin interval at a time. Your childhood is not available to you. A report of it is, filed by memory, summarized and compressed, and partly invented. Yesterday is a report. The first half of this sentence is already a report. What you actually have, what you have ever actually had, is a narrow window of immediate presence, and psychologists have measured its width. They call it the specious present, the span of time that feels like now, the interval you experience as a single unified moment rather than as a sequence of reports. The term entered science through a writer named E.R. Clay and was made famous by William James, the founding figure of American psychology, in his Principles of Psychology in 1890. Depending on how it is measured, the window's width runs from a few dozen milliseconds, about a 20th of a second, the timescale on which two flashes fuse into one, up to a ceiling of roughly 3 seconds, the span across which the brain binds events into one experienced unit, the length of a spoken phrase or a held glance. Between those bounds sits everything you have ever called the present moment. You can catch the window's edges at work in ordinary life, once you know to look. When two clicks arrive, less than about a 50th of a second apart, you hear one click, the pair falls inside a single frame of the present, and the brain files it as one event. Musicians live at this boundary. Notes played within a few hundredths of a second of each other register as together, and the together of an orchestra is really a swarm of near misses inside everyone's window. At the other end, the roughly 3-second ceiling shows up with eerie regularity. Studies of speech find we parcel talk into phrases of about that length. Lines of poetry across unrelated languages tend to take about 3 seconds to say. Even the spontaneous segmentation of everyday movements, a handshake, a stretch, a sigh, clusters near 3 seconds. Some researchers call it the feeling of nowness, the width of the room that consciousness furnishes. Anything longer must be handed to memory. Anything shorter fuses. You have been living inside these walls since before you could speak, and tonight may be the first time anyone has pointed at them. Set that width against the thread it slides along. Your world line, if you live 80 years, spans about 2.5 billion seconds. Your window of actual presence is, at its widest, 3 of those seconds, and at its narrowest, a 20th of one. As a fraction, the immediate now you occupy is roughly 1 part in a billion of the life you own. Everything else, every other address on the thread, reaches you only as testimony, the testimony of memory, faded and editable, or the testimony of anticipation, which is guesswork wearing confidence. You hold the deed to a billion-room house, and you have only ever stood in one room at a time, in the dark, holding a candle that lights 3 steps at most, taking the rest of the mansion on faith. This is the human condition stated in the block's own vocabulary, a thread 2.5 billion seconds long, lit by a moving window, 1 part in a billion wide. And the strangest part is not the narrowness. The strangest part is that there is a lit window at all, because nothing in physics says there should be one. To feel the full strangeness, try a comparison that the philosopher of physics tradition has sharpened into a lovely instrument. Imagine drawing a map of a garden, a good one, the paths, the beds, the pond, every bench and stone. Nothing requires you to mark your own position on it. A map with no "you are here" is not defective. It is simply a map of the garden, complete and self-sufficient, and you can hold it, admire it, use it, without the least sense that something is missing. Now try the same exercise with a stretch of time. Draw a map of your week, Monday through Sunday, every event in place, a small, clean diagram with time running left to right. It can be done. Calendars do it. But notice what happens when you look at it as a picture of reality. Without a mark saying now, the map feels hollow, a schedule, not a week. Something enormous is missing. Which day it is. So add the mark. Place a dot on Thursday afternoon, now. But the you of Monday would have placed the dot on Monday with the same total conviction, and the you of Sunday will place it on Sunday. To be fair, you must dot every instant, at which point the dots mean nothing, and you are back to the bare schedule. A map of space is complete without your position. A map of time without your position seems to be missing the only thing that matters, and with your position marked everywhere, the mark dissolves. Why the asymmetry? Why can you leave yourself out of the garden but not out of the week? No equation answers that. The asymmetry lives entirely on your side of the glass, in the fact that awareness is spread comfortably across space, taking in a whole garden at a glance, but is clamped, vice-tight, to one thin interval of time. That clamping deserves a name, the localization of awareness, and it is a genuine, unexplained datum about the universe. You might reach for an explanation from physics itself. Physics is local, after all. Fields interact point by point. Influences travel no faster than light. The light cones enforce neighborliness everywhere. Perhaps awareness is temporally local because the dynamics underneath it is local. But that answer, examined, does not finish the job. Locality constrains how influences propagate. It does not dictate the width of an experienced moment, or that there be experienced moments at all. The processes underpinning one flash of your awareness span, comfortably, a few hundred milliseconds of brain activity, but processes could in principle integrate over minutes, days, or decades of a world line. Nothing in the laws forbids a mind whose single present is a year wide. Nothing in the laws explains why yours is a 20th of a second. The width of the now is not written anywhere in physics, and yet it may be the single most consequential number in your existence, because it is the aperture through which the entire universe, block and all, gets rendered into experience. And here a suspicion begins to form, the most important suspicion of the night. We searched the glass for the fire and found stillness. We searched the equations for the now and found nothing. But we have just found, in the structure of awareness itself, a moving lit window of almost exactly the right description. Narrow, unique seeming from the inside, sliding steadily futureward along a world line at 1 second per second of proper time. What if the fire was never in the glass? What if passage, the flowing, burning now that no equation contains, is not a feature of time, but a feature of the witnessing of time? On this view, Whale had it exactly right. The world does not happen. The happening is the crawl of the gaze. The present would then be like the sensation of sweetness, not in the sugar, not in the glucose molecule, but in the encounter between molecule and tongue. Real, but relational. The universe would contain no current, only threads, and wherever a thread is elaborate enough to fold experience into itself, a current would seem, from inside that thread, to run. It is an elegant possibility, and it may well be the truth. But do not let it settle too quickly into comfort, because it comes at a price that few who propose it pause to count. If the flow of time is a construction of the mind, then the mind is constructing the most pervasive feature of reality as we live it, which promotes the mind from a late arrival in the universe's story to the author of its most intimate quality. And it hands physics a new debt, for if the fire is in the witness, then no account of the world is complete until it explains the witness, explains why there is an inside to certain threads of the glass at all, and why that inside has a 50-millisecond heartbeat. The problem of time, chased all night through trains and galaxies and geometry, ends up standing quietly at the door of the oldest question there is, the relation between mind and world. Physics did not expect to arrive here. It arrived here by being rigorous. There is one more way to loosen the grip of our assumptions, and it is gentler than everything in this part. Almost playful. We have been speaking of the window's width as though a 20th of a second were simply what a now is. But you share this planet with minds whose windows are not your width. To a housefly, your swatting hand drifts. To certain birds, your flickering screens strobe, and imagination can stretch the dial further, out to a mind whose single now is a century wide, a mind that would read the glass block not as a frozen slab, but as music. Meeting those other widths of now is the next stage of our night, and it will quietly change what you think the block looks like. Scientists have a way of measuring, at least roughly, how finely an animal resolves time, and it is wonderfully simple. Show the animal a flickering light and speed up the flicker. At some point, the flashes blur into a steady glow, the visual system can no longer separate them, and that threshold is called the critical flicker fusion frequency. For humans, it sits near 60 flashes per second, which is why older screens refreshing at low rates gave people headaches, and why film at 24 frames per second, with some optical tricks, passes as smooth motion. Your seamless visual world is an achievement of blurring, reality, sampled about 60 times a second, stitched into apparent continuity. That number, 60 Hz, is one measurable edge of your window of now. Other animals return other numbers. Dogs come in around 75 flashes per second, which means a standard old television, flickering at rates a human eye smooths over, could look to a dog like a slideshow. Many songbirds resolve around 100 flashes per second. A starling watches the world in finer temporal grain than you do, which makes sense for a creature that maneuvers through branches at speed and lands on a swaying wire without thinking. And the insects go higher still. Some flies resolve flicker at 250 flashes per second and beyond, roughly 4 times your resolution. This is one reason a fly is so absurdly hard to swat. In the fly's rendered world, your incoming hand does not dart. It eases, with all the menace of a cloud shadow, leaving ample subjective room to step aside. In 2013, a research team led by Kevin Healy gathered these measurements across dozens of species and found the pattern behind them. Temporal resolution tracks body size and metabolic rate. Small, hot-burning animals slice time finely. Large, slow-metabolizing animals slice it coarsely. A leatherback turtle registers roughly 15 flashes a second. The fly, 17 times more. The window of now is not a constant of nature. It is a biological setting, tuned by evolution to each body's needs. Narrower here, wider there, across the whole animal kingdom. Evolution's fingerprints are all over these settings, and seeing why makes the arbitrariness of your own now vivid. Fine temporal resolution is expensive. It demands fast photoreceptors, hungry neurons, a metabolism to feed them. So each species buys only as much present as its life requires. A fly's life is measured in weeks, and its dangers arrive in milliseconds. It pays for an ultra-thin now, because the alternative is being eaten. A leatherback turtle, armored and unhurried, drifting through a world of slow currents and slower jellyfish, has no need for an expensive fast lens on reality, and does not carry one. Predators that chase fast prey run hotter clocks than ambush hunters that wait. Some deep-sea fishes, living where nothing moves quickly and light is scarce, resolve just a handful of frames per second. Your own 60 Hz window, in other words, is not a revelation of time's true grain. It is a budget line. The width of present your ancestors' survival could justify, on a savanna, at a body size of tens of kilograms, at a mammal's operating temperature. Had you descended from different bodies with different dangers, this moment, this exact felt now, would be a different width, and you would be equally certain that its width was simply what a moment is. Let the implication land softly. Every one of those creatures inhabits the same block, the same glass, the same threads. Nothing about space-time changes between the fly, the starling, the dog, and you. What changes is the width of the lit window crawling along each world line, and with it, the entire felt character of reality. The fly's universe brims with duration. Events that are instantaneous for you are, for it, leisurely. The turtle's universe is a swifter, more blurred affair. Same physics, different nows, which quietly corrodes the last of the present moment's authority. Tonight began by dissolving the idea that your now is shared across space. Andromeda took care of that. Now biology dissolves the idea that your now is even shared across a living room. The moment you call this instant is not a feature of the universe. It is a rendering preference, one species' compromise between metabolic cost and the speed of its predators. So stretch the dial, and stretch it without apology, because nothing in physics forbids it. Imagine a mind whose specious present is not a 20th of a second, nor 3 seconds, but a century wide. You are that mind now. You stand, though standing is not quite the word for something whose single thought takes 100 years, above a stretch of the Earth's thread, and you are perceiving, in one unified moment, an interval that human beings would parcel into 4 generations. What do you experience? Not a frozen slab. Seasons pulse through your now, the way a violin's vibrato pulses through a single sustained note, a warm shimmer, felt as texture rather than sequence. Cities are not built and abandoned within your moment. Cities bloom and fade as one perceived event, a flower opening and closing in your palm. A forest's advance across an abandoned valley is a single gesture, green and slow and complete. Human lives, entire lives, birth to death, thread through your present the way individual notes thread through a chord you are still hearing, begun, finished, and somehow wholly present at once, not as loss, but as harmony. You do not watch any of this happen, exactly. It is all just now for you, one wide luminous moment, thick with a century of structure. And here is the vertiginous part, gazing down at the smaller minds, at the human world lines flickering their 20th of a second candles along their threads. You would find their claim that reality is a thin moving slice, as quaint as they find the fly's drifting dreamlike hand, where, in this stack of nested nows, fly, human, century mind, is the real width of the present. The question dissolves as you ask it. There is no real width. There are only windows. and notice what the century mind does to the central complaint of the night. The complaint that the block looks nothing like time, that a static four-dimensional structure fails to capture flow. Perhaps a structure fails to look like time only from inside a window too narrow to take it in. A single musical note, heard alone, contains no melody. You would swear melody was something else entirely, something a mere sequence of frozen notes could never hold. But widen the window that hears, and the melody appears, not added to the notes, but revealed as what the notes taken together already were. To the century mind, a stretch of the glass block may simply feel the way a phrase of music feels to you. Structure and flow at once, pattern and passage, as one thing rather than two. If that is right, then the block's frozen appearance was never a fact about the block. It was a fact about the 50-millisecond aperture we were forced to view it through, a keyhole complaint, mistaken for a flaw in the room. It is a hopeful thought, and it deserves its weight. Perhaps nothing is missing from the physics except a wider way of seeing it. But hold the hope loosely, because a keyhole explanation of the missing flow still leaves the keyhole unexplained. Why awareness comes in windows at all, why yours has the width it has, why the window slides futureward rather than resting still. And there remains one more piece of unfinished business, one that has been waiting patiently since the strollers passed beneath Andromeda. Everything tonight has flowed from the loss of the universal now, but that loss was proven inside special relativity, the physics of empty space and constant motion. The actual universe is not empty, and its contents are not featureless. It is filled, in every direction, with a faint glow, the oldest light there is, and that glow does something almost miraculous. It very nearly hands back what Einstein took away. Very nearly. The universe, it turns out, keeps something like a clock, after all, and the story of why it is almost, but not exactly, a true cosmic now is the last piece of physics we need before the final verdict. Every direction you could point, day or night, the sky is glowing. Not with starlight, with something older. Fill a radio telescope's view with any patch of apparently empty sky, and it hums with a faint microwave signal, the same signal, everywhere, corresponding to a temperature of 2.725 degrees above absolute zero. This is the cosmic microwave background, light released when the universe was about 380,000 years old, in the era when the first atoms formed and space became transparent. It has been traveling ever since, roughly 13.8 billion years, stretching as the universe expanded, cooling from a blazing orange glow into this quiet microwave whisper. It is the oldest light that exists, and it soaks every cubic centimeter of space, including the room you are in. And for tonight's question, the question of the lost universal now, this ancient light changes the conversation in a way that surprises many people who know only special relativity. Here is why. Special relativity's democracy of observers, no preferred frame, no privileged now, was derived for an empty universe, a featureless arena. The actual universe has contents, and the contents pick out something. Move through the microwave background at high speed, and the glow ahead of you shifts slightly hotter, the glow behind slightly cooler, a temperature dipole, painted across the whole sky by your own motion, which means there is, at every location in the cosmos, one special state of motion, the one in which the ancient light looks the same temperature in every direction, isotropic, balanced, no dipole. An observer in that state is at rest with respect to the universe's oldest light. And we know our own status. The dipole has been measured with exquisite care, and it says the solar system is moving at about 370 kilometers per second, roughly 1,000th of the speed of light, with respect to that restful state, toward a point in the sky, in the direction of the constellations Leo and Crater. In a universe whose fundamental laws refuse to name a preferred frame, the universe's actual contents seem to have quietly named one anyway. The dipole itself is worth a moment of respect, because it is one of the most precise whole-sky measurements ever made. The temperature difference between the warm patch ahead of our motion and the cool patch behind amounts to about 3 millikelvin, 0.003 of a degree, riding on a background of 2.725 degrees. Satellites, mapping the microwave sky, measure it so well that our velocity through the ancient light is known to a fraction of a percent, and the motion it reveals is a nested stack of drifts, the Earth around the Sun at 30 kilometers per second, the Sun around the galaxy at about 230, the galaxy pulled toward its neighbors, the whole local group of galaxies streaming, and the sum, that final figure of roughly 370 kilometers per second, is our total drift relative to the oldest light there is. Nothing in the laws required the universe to provide such a reference. It simply happens to, because it happened to begin hot and dense and everywhere at once, leaving a glow that fills all of space like a watermark. Any civilization, anywhere in the observable universe, pointing its instruments at its own sky, would find its own dipole and could subtract its own motion, arriving at the same shared rest, the same universal watermark. As common ground goes, no deeper has ever been discovered. And a preferred frame is exactly the ingredient a cosmic now would need. So build one. At every point in space, imagine the observer at rest with respect to the microwave glow. Call each of them a co-moving observer, riding the pure expansion of the universe, no extra motion of their own. Now knit their moments together. Define this instant everywhere as the moment when each co-moving observer's local universe reaches the same age, the same temperature of that background glow. Cosmologists do precisely this, and the construction has a name: cosmic time. It is what the famous number 13.8 billion years actually refers to, the age of the universe along the co-moving slicing. The knitting carves the block into a stack of universal moments after all. A foliation, physicists call it, a slicing of the whole four-dimensional glass into three-dimensional sheets of simultaneity, one privileged sheet for every cosmic instant. On this slicing, the question what is happening across the universe right now regains meaning. It very nearly is, the ledger of Newton, rediscovered inside Einstein's universe, written in the oldest light there is. So did the universal now just come back? Has the whole night been unwound in a single part? Feel the pull of that hope, because it is a real hope, and some serious thinkers have leaned on it. But now come the two honest qualifications, and they are the difference between an almost clock and a clock. The first, the construction only works approximately. The real universe is lumpy, galaxies here, voids there, gravitational wells everywhere, and the lumps disturb the knitting. The microwave background is not perfectly smooth. Its temperature ripples by about 1 part in 100,000, and local masses bend and delay light and drag on clocks, so the co-moving sheets cannot be drawn with perfect sharpness. Try to refine cosmic time from a good approximation into an exact, instantaneous, universal present. This precise instant, everywhere, no fuzz. And the procedure runs out of definition. You must start making choices, conventions, about how to smooth the lumps, and different reasonable conventions draw the sheets through space-time slightly differently. The universe offers cosmologists a magnificently useful bookkeeping time, good enough to date the cosmos and map its history. It does not offer the knife-edged universal instant that Newton's ledger promised, and that the argument of this whole night requires. Almost a now, not a now. The second qualification cuts deeper. Even where the cosmic slicing is well defined, it is a frame picked out by the arrangement of matter, not by the laws of nature. The dynamics, the actual machinery of physics, the thing that determines what can influence what, remains perfectly indifferent to it. Nothing moves differently, ages differently, or signals differently for a co-moving observer. The light cones stand exactly where they stood. The train and the platform still disagree, and are still both right. The microwave frame is special the way the floor of a ballroom is special to the dancers. A shared reference everyone can orient by, not a modification of the music. In the language of our night, the glow paints one particular slicing onto the glass block, and the paint is real and useful, but it is paint. The glass beneath keeps its own structure, and that structure still contains no universal present, no flowing current, no lit slice. An almost clock, painted on a block that does not tick. There is something almost poignant in how close the universe comes. It gives us one light, everywhere, from one beginning, a state of rest any civilization in any galaxy could find by the same measurement. A shared age, 13.8 billion years, that every co-moving observer would agree on, to good precision. If you wanted to send a message to be dated by beings on the far side of the observable universe, cosmic time is what you would both use. For every practical purpose of cosmology, the now is back. And yet at the exact point where practicality would harden into metaphysics, where the useful slicing would become the real present, the one lit moment, the current in the river, the universe withholds the last millimeter. The sheets blur, the conventions multiply, the dynamics shrugs. It is as if the cosmos were willing to lend us a now, but not to own one. So the verdict of the physics, surveyed end to end, stands as follows. Special relativity abolishes the universal present outright. General relativity, furnished with the actual universe, hands back a working approximation, a magnificent one, and declines, at the final decimal, to make it exact. The block remains standing, the fire remains missing, the window remains unexplained, which leaves only the reckoning. We have followed the idea from a patent office in Bern to the oldest light in existence. We have seen what it explains, what it consoles, and what it cannot find room for. The last part of tonight's journey is the honest accounting, the road still open, the price of each, and what it finally means that the deepest idea in physics remains, after 120 years, magnificently unfinished. Philosophy has a tidy shelf for the positions still standing, and it is worth walking past each one, slowly, like portraits in a quiet gallery. The first is Presentism, the view your nervous system was born holding. Only the present is real. The past has ceased. The future is not yet. It remains the picture most human beings would draw if handed a pencil. Its difficulty has been the whole of tonight. A universal present needs a universal now, and relativity provides none, and the almost now of the microwave sky arrives blurred and optional, a bookkeeping convenience the underlying laws ignore. A presentist today must argue that reality's most basic feature is something no experiment has ever caught a trace of. Some careful thinkers still hold the view, but they hold it against the grain of the physics, and they know it. The second portrait is the growing block, proposed by the philosopher C.D. Broad in 1923. Past and present are real, the future is not, and reality accretes. The block grows, moment by moment, like tree rings, with the present as the fresh outermost layer. It is a lovely compromise, keeping the fixed past and the open future of experience. But it inherits the same wound. The growing edge is a universal, now wearing a construction hat, and relativity will not survey the site. Whose slice is the edge? The theory cannot say. The third portrait is the one the night has painted in full. Eternalism, the completed block, all events equally real, no edge, no current. The picture that fits the equations like a glove, and fits your Tuesday like a shoe on the wrong foot. And beside these hangs a smaller sketch, the Neo-Lorentzian option, which keeps a secretly preferred frame, a true universal time, hidden behind the relativistic effects, forever undetectable by any experiment. It cannot be ruled out. Undetectable things never can. Most physicists decline it for exactly that reason. And now that the universe conspires perfectly to hide, is a heavy purchase for a comfort no measurement will ever cash. This standoff has a history older than relativity, and it deserves one paragraph of respect. In 1908, the same year Minkowski spoke in Cologne, the philosopher J.M.E. McTaggart published a paper called The Unreality of Time, in which he distinguished two ways of ordering events. The A series orders them as past, present, and future, tensed, flowing, centered on a moving now. The B series orders them as earlier than and later than, tenseless, fixed, relational, no now required. Every clock and calendar uses the B series. Every human heart uses the A. McTaggart argued the A series was contradictory, and time therefore unreal. Few followed him that far. But his two series became the permanent vocabulary of the debate, and notice what relativity did to them. It took sides. The B series is exactly what survives in the block. The light cones, the earlier and later of causal order, absolute and observer independent. The A series is exactly what went missing. The now that no frame can own, the flow that no equation contains. Physics vindicated one series and orphaned the other, and human experience, unbothered, goes on being made entirely of the orphan. One more figure walked these galleries and deserves his single line. In 1949, the logician Kurt Gödel, Einstein's closest companion in his Princeton years, found solutions of Einstein's own gravitational equations describing rotating universes in which time's passage could not be objectively defined at all, and argued that if passage fails in a possible universe, its standing in ours is suspect. Einstein took the argument seriously and admitted it disturbed him. That story deserves its own night someday. Here it stands, simply as one more voice from inside physics' innermost circle, testifying that the doubt about passage is not a modern fashion, but a wound the founders knew intimately. It is worth saying, briefly, that this pattern, a formalism that captures the structure of the world while omitting the felt actuality of it, may not be unique to time. In the quantum theory, on certain readings, something similar goes missing. The mathematics carries every possibility in perfect superposed order, and the plain fact that one particular outcome actually occurs, this result, this world, this click of the detector, has no representative in the formalism, and must be added by hand or argued away. The felt now and the felt actual, two of the most intimate certainties there are, and the two great theories of the 20th century each misplace one. Perhaps that is coincidence. Perhaps it is the same lesson arriving twice, that a view from nowhere, however powerful, purchases its power by deleting the very standpoint from which anything is ever seen. Theologians spent centuries debating a mind outside time, holding all moments in a single regard. Physics, without intending to, built that view's mathematical twin, and then discovered it could not find its way back inside. So let the accounting be honest, because honest accounting is the only luxury a channel like this owes you. Here is what is established, as firmly as anything in science. There is no universal present. Simultaneity is relative. Different world lines contain different amounts of time. The muons and the flown clocks and the satellites settle this beyond argument, and the arithmetic of the Andromeda walk follows with the force of logic. Here is what is strongly supported, but not compelled. The block. All moments equally real, as the cleanest reading of those facts. You may resist it, but every escape route runs through undetectable scaffolding or unfinished edges. And here is what nobody on earth knows: why time passes. Whether the fire lives in the world, awaiting a deeper physics that would make passage as real as charge, or lives in the window, in the 50-millisecond aperture of awareness, in which case the mind writes the most vivid sentence in the book of nature, that question stands open tonight, in every laboratory and every philosophy department on this planet, exactly as open as when Augustine confessed his bafflement 16 centuries ago. The idea is magnificent, confirmed, and incomplete. Understanding it, including understanding precisely where it ends, is what it means to understand physics. Anyone who tells you the matter is settled, in either direction, is selling a souvenir of a journey they have not taken. And now that you hold the whole of it, return one last time to the sentence you were asked to keep at the very beginning. Time is how long you have to wait. It sounded like a joke when Feynman said it, a shrug from a man who could calculate anything. Hear it again now, on the far side of the glass block, and the shrug has become precision. The waiting, the felt stretch of duration, the arriving of moments one by one, is exactly the part of time that the equations do not carry. The block holds every event, the light cones hold every order, the microwave sky even holds a serviceable clock. None of it waits, only you wait. Feynman's definition, it turns out, was not a joke at all. It quietly pointed at the one ingredient physics has never captured, and called it the whole of time. What breathes fire into the equations? Hawking asked. And tonight the closest thing we have found to an answer is this. Whatever it is on your side of the glass. It is the thing reading the equations. It may simply be you. Before the final thought, let the whole night settle into a single quiet image, the way a long walk settles when you finally sit down. Somewhere in the glass, there is a thread that is you, and tonight is on it. This hour of listening, this drowsy room, this voice, already woven, already part of the pattern, alongside every other hour you have lived, a hand's width down the time direction. There is a morning. You will wake into it, and it will feel, as every moment has ever felt, like the one lit room in the universe. It will not be, or rather, it will be exactly as lit as this one, and as the summer afternoon, and as the far end of the thread, and the light will be the kind you carry, not the kind you find. Of all the things physics has ever told us, this may be the hardest to hold and the most worth holding. The universe does not distribute presents, it distributes events. Presence, the lit, warm, unrepeatable feel of now, appears to be your contribution, the one thing you bring to the glass that the glass does not already contain. Whatever awareness turns out to be, it is the only place in the known universe where the block universe ever feels like anything. Tonight, for a while, it felt like this. If the block is right, then one more thing is true, and it is worth carrying into sleep. Nothing is lost, not one moment. The afternoon you keep trying to remember in full, it is not fading out of existence. It is exactly where it always was, complete, at its own address in the glass, as real as tonight. The people no longer here have not been erased from the universe. Their threads lie whole in the block, every laugh at its coordinates, and the distinction that seems to separate you from them is, in Einstein's words, a stubbornly persistent illusion. He wrote that to a grieving family in his last weeks, and he meant it as physics, not poetry. Perhaps that is the gentlest thing this strange idea offers, a universe where nothing that ever mattered stops being real. It only stops being now. And the now, as we have seen, was never the universe's to give. It was always yours. Thank you for keeping me company on this long walk through the deepest idea in physics, from a patent office in Bern to the light older than every star, and back to the small lit window where you have lived your entire life. If this kind of slow unraveling of reality is how you like to end your day, a quick like or a subscribe would mean a great deal. It genuinely helps me keep making these. And remember, the next time you catch yourself waiting for a kettle or a train or sleep itself, that quiet stretch of waiting is the one piece of time all the equations in the world have never managed to hold. Good night, and may you never look at a passing moment the same way again.